Oh, hi there. Thanks so much for showing up here, Math Learning. It's Tutor Grant, and we're going to take a look at how we can use a visualization strategy to visualize this quadratic over here, and then imagine the line y equals 9 to verify our algebraic work that we're also going to do going down here. So the first step in visualizing a quadratic that's written in this form, where it's the product of two brackets, the product of two binomials, is to find our zeros. So 1 0 is going to come from here. If 3x plus 8 equals 0, then that means 3x equals minus 8 and x equals minus 8 on 3. So minus 8 on 3 is a little bit smaller than minus 2, but bigger than minus 3, so it's about there. So we have a 0 there. That's one of our points. Minus 8 on 3, 0. And then this one will also give us a 0. If 2x minus 3 equals 0, then that means that x equals 3 on 2, which is, if this is 1 here, it's halfway in between. It's right there. So that's 3 on 2, 0. Okay, and notice I didn't waste any brain power converting those to decimals, because why would you? Just get comfortable with fractions. All right, and then the next step in visualizing this quadratic is noticing that these two multiply. When we expand and simplify this, that's going to give us a 6x squared. The coefficient of that determines that it's been stretched vertically and it opens upwards. So our final quadratic is going to be opening this way somehow, and this way somehow, and having a vertex that's somewhere in the middle. I would say somewhere probably like, I don't know, down around there. And then we're going to look something like this and something like this. Okay, so there's our quadratic. If y equals 9, well, that gives us, just underneath that 10 there. So what I'm finding is that I'm going to have one solution that's out there in the realm of like maybe x is a little bit less than 2 is my guess, and then one just over here, maybe that's minus 3, right? Like maybe that's exactly on minus 3. We're right in that range, like x is equal to ish minus 3. Okay, so we get this visual sense of where they're going to be. Now we go ahead and do the work. So the work is, first we expand. So 3x times 2x gives us 6x squared. 3x times minus 3 is minus 9x. 8 times 2x is plus 16x. And 8 times minus 3 is minus 24. And that's equal to 9. We are going to set this to 0, so let's subtract 9 from both sides while we're at it. And then we get the next line, 6x squared minus 9 plus 16 is going to be plus 7x minus 33 equals 0. Okay. So that is expand and simplify that to the max. It's going to be one of our options to drive this towards a solution. Now that we've got it here, it's not like on the ropes per se, but we get to now decompose that middle term. So I'm going to switch ink and take these two numbers and multiply them. So this I'm going to have 6 times minus 33, which is the same thing as minus 99, is minus 198. Okay, so I multiply those two numbers, minus 198, yes, that is correct. And then I just take this number here and put it down there. So what I'm looking for are two numbers that multiply to 198 and add to 7, and have a difference of 7, okay? Because they multiply to a negative number, so one of them is positive, and one of them is negative. The bigger one is positive. So let's take a look at the factors of 198. I happen to know the factors of 198 are 6 and 33, because of course I know that. We just multiplied those. And that's so 2 times 3 times 3 times 11. And I want to find a way to arrange these so that they have a difference of 7. 22 and 9 doesn't quite work, does it? But what about 2 times 3 times 3? That's 18. So these come back together to make 18 times 11, and that has a difference of 7. So 18 and 11, and if you can tell I haven't done this problem, I created this problem, but I didn't do it yet. This is true. Okay, so now I'm just going to break this plus 7x down into two pieces. 18x minus 11x. I didn't change anything, I just wrote it in two pieces. And then I still have 6x squared plus that minus 33 equals 0. And then we can factor both of these by grouping. So the biggest factor in this group is actually 6x. So I have 6x multiplied by x plus 3. And that would give me this group up here. And then over here, my biggest factor is minus 11. And that would be multiplied by x plus 3. I want to create that same binomial factor in both spots. That's why I factor out a minus 11, not a positive 11. And then I just group the leftovers together. So I have 6x minus 11 multiplied by x plus 3 equals 0. And now I have two things multiplying. One of them must be 0 if this is true. So, and actually either one could be 0. So either 6x minus 11 equals 0, meaning 6x equals 11, and x equals 11 sixths. Okay, or x plus 3 equals 0, and x equals minus 3. And then we go ahead and check it against our visualization, just to see if we're right. Okay, so we said x might be just a little bit less than 2 over here. Ho, 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 look at that. Look at that, so satisfying. X is 11 sixths, ever so slightly smaller than 2. And then here, x might be exactly minus 3. Oh, look how cool the visualization was. It was so useful to just to verify that, yes, we have the correct answer. So I hope you enjoyed calculating your way through these as much as I do. They're kind of like little treasure hunts. And I want to give you a method for creating your own problems. You can even use this tool to analyze these ones that I created for you to solve. And you're going to create your own problems for one another to solve. So let's go over here. So if I go into Desmos, here I have the quadratic that we were looking at. So there it is. And then all you need to do is just type out a quadratic like that. Build your own quadratic that's in factored form like this, and then your classmates will visualize this, just like I did, by finding the roots. Okay, so here are the roots, boop and boop. Okay, same roots we found. These are converted to decimals, whatever. All right, and then what you can do is just like create like a y equals line. Let's say y equals 1, and then if you like these points, no, they're not integer points, are they? Let's put on like more of a grid. Yep. Show me the minor grid lines. There we go. So I'm looking actually for points where this thing binks a grid line, like a grid line point. So if I go up here to 9, right? Like I found this one 9 here, where it hits an integer point, it hits a lattice point. So I can move this and just verify that, yeah, once that hits one integer point on one spot, the other side it'll be factorable. Don't have any worries about that. There's 11 sixths. Okay, so let's find another one. Looks like this one's good, right? This one here, minus 2. Yeah, minus 2, minus 14. That's good. That would be factorable. What about minus 1? The x is minus 1. So you can just go ahead and hunt for them, right? And just look at them this way. Where is it? Oh, it's like minus 25. Yeah, minus 25. So if we did like y is minus 25, we'll see that it has these two solutions. And I could have made this the problem, right? And that looks like negative a sixth. So you would find that by factoring. Right? This is how you build them. Just go ahead and go for it. Find points where it's like just like hits lattice points. Is that one? No, that one won't do. That's like some junk. Oh wait, no, it's minus 9.9. Actually might do. Who knows? If I did this, and I look there, that's a bunch of junk, and that's a bunch of junk. This is a lesson for another day, finding the junky points. But if I look like, say, at -6 looks good. I don't know, I'm -8. You can just type it. -6, let's see. No, it's no good. But you can also just do this. This one makes it easier to find. X equals, let's say, -2. Right? And then we find this one. Oh, -14 would work. So I can say y is equal to -14. And find that one, and those would certainly be findable. That's 5/6 over there. So this is how you can build your problems. And then once you've got that, you can just like say, okay, well, I want this to be equal to -14. Your graph changes a little bit, but it's really just showing you your solutions at this point. Okay? And then copy that into the chat so that other people can solve it. And that's the method. Okay, I will give everyone who does this participation points for practicing your quadratics and helping your classmates practice their quadratics. Bye for now, everyone.